Hi students, for Pythagorean theorem number 3, we'll be looking specifically at what the side lengths are for the legs and the hypotenuse, along with what the areas of the squares are. With that said, we're going to start with this first one. The instruction reads as follows. Find the length of the legs and hypotenuse of each triangle. Be sure to find the area of each square. Okay, so in order to find the length of the legs and hypotenuse for each of the triangles, we need to find the area of each square first. So we know that the formula, one of the formulas for the Pythagorean theorem can be written as leg 1 squared plus leg 2 squared equals the hypotenuse squared. And one of the first things we want to do is identify where the hypotenuse is, and it's always across from the right angle. And you can think of that as the longest side. And we'll call the other lengths to be the legs, so leg 1 and leg 2. So leg 1 squared, the square of leg 1 is going to be 25. Leg 2 squared, so the square of leg 2 will be 40. So 25 plus 40, and that equals the hypotenuse squared. And we don't know the area of that yet. So 25 plus 40 is 65, and that equals the hypotenuse squared. If we want to solve for the hypotenuse, just the length of the hypotenuse itself, we take the square root of both sides, and we get the hypotenuse is equal to the square root of 65, because no two numbers multiplied can equal to 65. That is a whole number. So now we can fill in our information. We know that 25 is one of our areas for the squares. The other one's 40. 25 plus 40 is going to equal 65. And our missing side lengths are, so this 25, the square root of 25 is going to equal to 5. And the square root of 40 is going to equal to the square root of 40. Because nothing times something cannot equal 40 as a whole number. And then square root of 65, as we discovered a little earlier. So we fill in our information. The length of leg 1 is going to be 5. The length of leg 2 is going to be square root of 40. And the length of the hypotenuse is going to be the square root of 65. So another way to think about the Pythagorean theorem is a squared plus b squared equals c squared. So we'll find where the hypotenuse is right here. So we'll call that c, and then we'll call this a and b as our legs. So a squared is going to be 64. So the area of a as a square is 64. And b squared, the area of b, we don't know what that is yet. So we'll continue to call that b squared. And that equals to c squared. So the area of the length of c is going to be 100. So we have 64 plus b squared equals 100. Notice how this time we're trying to find the leg, not the hypotenuse, like we did earlier. So to find the leg, we're going to subtract 64 on both sides to isolate for b. We get b squared equals to 36. Then we square root both sides, and we get b is equal to 6. Now we can start writing our information in. We know that b, the length, is going to be 6, and the area is going to be 36, because 64 plus 36 is equal to 100. A squared, 64, plus b squared, 36, is equal to c squared, which is 100. And the square root of 64 is going to be 8. And the square root of 36 is going to be 6. And the square root of 100 is going to be 10. That's how we find the side lengths for each of the legs and hypotenuse. So number 2, made a little typo. Number 2 states that draw the squares for each leg and hypotenuse to find out the missing side length. Show your work. So this is very similar to Pythagorean theorem number 2 worksheet. So we'll first start by drawing the legs of our the squares of our legs and hypotenuse. So that's my hypotenuse. I'm going to call that H. This is my leg 1, and this is going to be my leg 2. Okay, there we go. Now, we know that the formula is leg 1 squared plus leg 2 squared equals the hypotenuse squared. So leg 1, we don't know what it is, so we'll call it x squared plus leg 2 squared, which is going to be 12 squared, is equal to h squared, which is 15 squared. X squared plus 12 squared is 144, and 15 squared is 225. To solve for x, we are going to subtract 144 on both sides. And we call it x because we don't know what it's called, what the answer is. So x squared is equal to 5 minus 4 is 1, 2 minus 4 is 8, and we borrow from the 2, which is 1. So 81, x squared is 81. Then to solve for x, we square root both sides, and x is equal to 9. That tells us leg 1, which is our unknown, is going to equal to 9. That's our length. And then the area of the square with the leg of 9 is going to be 81, because 9 times 9 is 81. And then 12 times 12, so the area of this square right here for the other leg will be 144. And 15 times 15, which is the hypotenuse squared, is equal to 225. 81 plus 144 equals to 225. So leg 1 squared plus leg 2 squared is equal to hypotenuse squared. We're going to do the same thing for the second problem. Draw in our legs, draw in our hypotenuse, draw in our other leg. So we'll try the other formula. A squared plus b squared equals c squared. So look opposite to find my hypotenuse, which is c, and we'll call the other legs a and b. So we know that a squared is going to be 3 squared plus b squared, which we don't know what it is yet. We'll call that x squared or b squared, either one, something we don't know, equals c squared, which is our 7 squared. 3 squared is 9, plus x squared equals 7 squared is 49. Subtract 9 on both sides to get x by itself, and we get x squared equals to 40. Then we square root both sides to get x alone, and x is the square root of 40. So now we fill in our information. So we know that 3 times 3 is going to give us an area of 9. 7 times 7 is going to give us an area of 49. And square root of 40 times the square root of 40 is going to give us an area of 40. And you can see that this applies to the Pythagorean theorem because a squared, 9, plus b squared, 40. 9 plus 40 equals c squared, 49. 9 plus 40 equals 49.